Hello students, in the last lecture we discussed potential energy of SHO, kinetic energy of SHO and total energy of SHO. Now we want to draw the graph. Okay, first we draw the graph versus displacement then time. Okay, means first we draw the graph of potential energy versus displacement, total energy versus displacement and kinetic energy versus displacement, right? First we want to draw the graph of what? Potential energy versus displacement, total energy versus displacement and then kinetic energy versus displacement. Okay, chalo. So now first, what is the formula for potential energy? Potential energy is equals to half kx square. Potential energy is equals to what? Half kx square. Total energy means then kinetic energy half k a square minus x square. What is kinetic energy? Half k x square minus a square. And what is total energy? Half k a square. Okay, what is the total energy? Half k a square. Chalo. So these are the formula for potential, kinetic and total. Chalo, now we want to draw the graph. So first we draw the table, students. See here, displacement, potential energy, kinetic energy and total energy. Okay, we draw the graph of what? Potential, kinetic and total. Chalo, first we consider, students, first we take the value of displacement is x, a. What is the amplitude? What is the displacement? A, amplitude. Displacement is equals to amplitude, maximum displacement. So when x equals to a, what is the potential energy? See, potential energy is equal to half kx square. So when x equals to a, what is the potential energy? Half k a square. What is the kinetic energy? If we here place a square, then what is the kinetic energy? If in the place of x, if we write a, then a square minus a square. What is the kinetic energy? 0. Okay. What is the kinetic energy? 0. So it means what, students? See, at x equals to 8 means at maximum position. As we know, at maximum position its velocity becomes 0 because at maximum point spring or any oscillator comes to rest and then moving in a downward direction. Okay, so at maximum point, at maximum position, velocity is 0, so kinetic energy is 0. So at highest point kinetic energy is 0 and potential energy is maximum. What is the total energy? Means potential and potential plus kinetic. So what is the total? Half k square. Chalo, now next case. Now x equal to 0. So at x equals to 0, what is the potential energy when at x equals to 0? 0. What is kinetic? If we place here x equals to 0, then what is the kinetic energy? X equals to 0 is known as mean position. So when oscillator passes through mean position, its velocity is maximum. As we know, at mean position velocity is maximum. What is that velocity? Omega a. So at mean position velocity of oscillator is maximum. So its kinetic energy is also maximum. What is the total energy? Potential plus kinetic. So what is total? What is the total energy? Half k a square. What is the total? Half k a square. So same. Now we take x equals to minus a. If we take here x equal to minus a, then what is the potential energy? Half k a square. If we take x equals to minus a here, then what is the potential energy? Half k a square. What is the kinetic energy? Half k a square minus a square. So minus square become positive. So what is the kinetic energy, students? 0. Okay, so at extreme position kinetic energy is 0 because velocity becomes 0. So again, what is the total energy? Potential plus kinetic. So see students, total energy remain constant. What is the total energy? Half kx square, that remain constant with the distance. So now draw the graph. Here we consider energy. Okay, on y axis we consider what? Energy, and here we consider displacement x. Okay, here we consider what? Displacement x. Chalo. Now next student, see, we consider three values. X equals to a, x equals to 0, and x equals to minus a. X equals to 0, x equals to a, and x equals to minus a. Okay, chalo. So we consider the three position: x equals to a, x equals to 0, and x equals to minus a. Chalo. So we consider 3, a, 0, minus a. Chalo. So now see students, now how to draw the graph. First we draw the graph of suppose first we draw the graph of potential energy. So see students, at x equals to 0, what is the potential energy? 0. At x equals to 0, potential energy is 0. So graph of potential energy start from 0. Okay, so graph of potential energy start from 0. At x equals to a, potential energy is maximum. What is that? Half k a square. At x equals to a, what is the potential energy? Half k a square. So at x equals to a, potential energy half k a square means become maximum. So at x equals to a, potential energy become maximum, that is what? Half k a square. So here, okay, again at x equals to minus a, again at x equals to minus a, what is the potential energy? Half k a square. Sure. Follow. Now for what students? Next is for Sure. Now next this is the graph for what? This is the graph for potential energy. Now we want to draw the graph of kinetic energy. See, at x equals to 0, what is the kinetic energy? At x equals to 0, what is the kinetic energy? Half kx square maximum. So it means graph of potential and kinetic energy start from maximum. Why? Because at x equals to 0, kinetic energy is maximum. See, half k square. So graph of potential energy start from maximum, because at x equals to 0, kinetic energy is maximum, half kx square. And x equals to a, kinetic energy is 0. X equals to minus a, again kinetic energy is 0. Okay students, now we want to find intersection point. Okay, now we want to find what? Intersection point. These are the graph, and this is the graph for what? This is the graph of kinetic energy. And what is the total energy? Total energy is constant, half k square. So this is the graph of total energy. This is remain constant, half k square. Chalo. Now we want to find intersection point, students. See, these two are the intersection point. A suppose P and Q are intersection point. So students, we can say that at P and Q, kinetic and potential. Now we want to find this intersection point. Now means we want to find for which value of displacement kinetic and potential energy are same. So see students, at P and Q we can say that at P and Q both are the intersection point. So we can say that at P and Q, at P and Q, kinetic equal to potential. At P and Q, kinetic equal to what? Potential. What is the kinetic energy? Half k a square minus a square. What is the potential? Half k square, k cancel, half cancel. So a square minus a square is equal to x square. So a square is equal to 2x square. So x square equal to a square by 2. So x equal to plus or minus a by root 2. What is x? Plus or minus a by root 2. So it means students, it means at minus a by root 2 and at plus a by root 2, at minus a by root 2 and plus a by root 2, kinetic energy and potential energy becomes equal. Now during that, what is the value of displacement that we want to find? What is the value of total energy? So students, it is basic question. See, when both are equal, then what is its energy? Total energy by 2. Okay, suppose total energy is 100 joule, then what is the kinetic and potential? 50-50. Okay, but how to prove? If we want to prove, say that what is the potential energy? Half kx square. But what is x? Plus or minus what is the potential? Plus or minus a by root 2. So it's square. So half k a square by 2. Okay, and half k a square, half k A square means what? E by 2. So when they are equal, what is the value of total energy? E by 2. Okay, when potential energy and kinetic energy are equal, what are their values? Total energy by 2. So what are the intersection points, students? Intersection points are plus or minus A by root 2 and E by 2. That is the intersection point, plus or minus A by root 2 and E by 2. The two are the what? Intersection point. Now students, next we want draw the graph of potential energy versus time, kinetic energy versus time and total energy versus time. Graph of potential energy versus time, kinetic energy versus time and total energy versus time. Next we want to draw the graph of potential energy versus time, kinetic energy versus time and total energy versus time. So students, now first if you want to draw the graph, then first we know the relation with the time. So students, in last lecture we derive this. What is the relation between potential energy and time? How to obtain? See, potential energy is half kx square. Then what is the equation of displacement? A sin omega t. Okay, if you want to obtain the relation with the time, then in the place of x, right, x equals to what? A sin omega t. So students, now we write here half k A sin omega t. So this is the what? Half kx square means it is a relation between potential energy and displacement. Now this is the what? Relation between potential energy and time. Okay, what is the relation between potential energy and time? Half Ka square sin square omega t. Chalo, now kinetic energy. Kinetic energy means half mv square. Kinetic energy means what? Half mv square. Now how to obtain V? Differentiate. V is equals to dx by dt. Kano differentiation karo students. So A, what is the meaning by speed? Dx by dt. So differentiate, then A as it is. What is the differentiation of sine? Cos omega t into omega. So omega A cos omega t. Omega A cos omega t. Chalo, now place here. So half m omega A. So half m omega square cos square omega t. Half m omega square A square cos square omega t. Now what is omega? Omega is equals to root k by m. So omega square is equals to k by m. Omega square is equal to what? K by m. Mm cancel. So what is the kinetic energy? Half K A square what is the kinetic energy? Half K A square cos square omega t. Chalo, then if we total students, then we get total energy. Okay, if we total, See, what is the total kinetic plus potential? So in both the case, half Ka square common. So sin square omega t plus cos square omega t, that is equals to 1. So what is the total energy? What is the total energy? Half Ka square. Chalo, right? Now next students, now how to draw the graph? See, what is the potential energy that we obtain? Half Ka square half Ka square sin square omega t. What is kinetic energy? Half Ka square cos square omega t. And what is the total energy? That total energy does not depend on time, it is constant with the time. Okay, so now we want to draw the graph. See students, if you want to draw the graph of potential energy with the time, then we draw the graph of sin square omega t. Okay, kono graph draw karo pade? Sin square omega t. So see student, we know the graph of sin omega t. What is the graph of sin omega t? This is the graph of sin omega t. Start from the 0. It is negative value 1, it is positive value minus. It is the graph of sin omega t. But here sin square omega t. So first half is same student, but હવે આ જે next half છે ને એ પણ ઉપર જ રહેશે. Why? Because why second half ઉપર જ ગયો? Because it is sin square and square always positive, એટલે negative માં નહીં જાય. Okay, so it is a graph of sin square. તમે ઓલો half wave full wave આવા ગ્રાફ જોયા હશે. So for cos omega t, what is the graph? This is the graph of cos omega t. Okay, again this is 1, this is minus 1. But if you want to draw the graph of cos square omega t, then first portion is same. Now is second portion. Now its second portion is shifting upwards students. क्या shift થઈ જશે? It shifts in upwards. Okay, so square ના graph હશે sin square કે cos square ના graph એ below the x axis ન હોય, ક્યાં હોય? upward. તો હવે એમાંથી આપણે એક important conclusion લેવાનું છે. So જોઈએ. What is the equation of displacement? Equation of displacement is a sin omega t, and this is the graph. This is its maximum value, a minimum minus. Chalo, so now we want to draw the graph of again here energy and here time. Okay, energy and time. So now students, now we want to draw the graph of potential energy versus time, kinetic energy versus time, and total energy versus time. So first we draw the graph of potential energy. See, in potential energy sin square is there. This is the graph of sin. So હમણાં વાત થઈ sin square, first part તો ઉપર, but second part બી અહીંયા જ આવશે students. So see students, in a same time અહીંયા one cycle complete થાય, તો અહીંયા કેટલી cycle complete થાય છે students? 2 cycle complete થઈ ગઈ. હવે તમને ખબર ક્યાંથી કેમ ખબર પડે કે cycle start થઈ, complete થઈ જાય? So students, એ એના oscillation પાછા same point થી ચાલુ થાય ને તો એને એક cycle પૂરી કહેવાય. See, this is its initial point. Now again it starts from the same point, then its one oscillation is complete. Okay, this is the initial point, starting point after it moving upward. So see, after this point again it moving upward. Now see, after this point again it moving upward. So see, this is the one oscillation, this is the one oscillation, second oscillation. So એના જે ઇનિશિયલ જે સ્ટાર્ટિંગ પોઈન્ટ આવી જાય ને પાછું સેમ, તો વન ઓસિલેશન કમ્પ્લીટ. જો હા અહીંયા સમજીએ, this is the starting point, then moving in upward direction. So again at that point it moving in upward direction. So it means one oscillation complete. Here also one oscillation complete. So see students, in a displacement one oscillation complete થાય ત્યારે કેટલા oscillation complete થાય છે? 2. આવું તમારા ફૂલ વેવ રેક્ટિફાયરમાં આવ્યું હશે. ફ્રીક્વન્સી ડબલ, ઇનપુટની ફ્રીક્વન્સી 50 હર્ટ્ઝ, તો ફૂલ વેવ રેક્ટિફાયરમાં 100 હર્ટ્ઝ. સો એમાં અહીંયા છે સ્ટુડન્ટ, સી here one cycle complete. So in case of potential energy, 2 cycle complete. So what is the frequency of potential energy? Double. Why double? Because here 2 cycle complete. Okay, this is the one cycle, this is second cycle. Cycle complete ક્યારે થાય students? જ્યારે એ repeat થવા માંડે ઇન્સ્ટોટ. ઓકે, જો હવે આ એક પેટર્ન તો પાછું રિપીટ થઈ ગયું, જો અહીંયા પણ રિપીટ થઈ, જો આફ્ટર ધીસ પોઈન્ટ એ રિપીટ થાય. સો દેટ ઇઝ વન ઓસિલેશન કમ્પ્લીટ. સો વોટ ઇઝ ધ ફ્રીક્વન્સી ઓફ પોટેન્શિયલ એનર્જી? ડબલ દેન displacement. Same students, you study in a full wave rectifier. Chalo, now we want to draw the graph of, chalo, this is its maximum energy, half Ks square. Chalo, now we want to draw the graph of cos square. Chalo, the cos square start from the maximum. Okay, again it does not moving in a downward direction. Chalo, so see, it's starting from that. So one cycle, again it start from the same point. So 2 cycle. So see, it is 1 cycle, it is 2 cycle. So see students, as we know, okay, in a kinetic and potential energy, 2 cycle completed. During same time in a displacement, 1 cycle is completed. So what is the frequency? This is very important note students. For SHM, frequency of kinetic energy and potential energy is double than displacement. Frequency is double than displacement. And what is the time period? Half. Frequency double, so time period half. Okay, and time period of kinetic energy and potential energy is half than displacement. So this is very important note students. Okay, frequency double and time period half, and this is the total energy, right? This is the total energy, does not change with the time, half Ks square. So we discuss the graph of kinetic energy versus time, potential energy versus time, and total energy versus time. Students, in the previous graph it versus displacement, and here this is the its important point, intersection point, and here this is the important point. Chalo, now see one MCQ students. For two spring A and B, spring constant of A and is much greater than spring constant of B. It means, see here spring constant of A is more than B, so A is hard. Spring A is hard compared to B. Okay, spring A is hard compared to spring B. So now both spring are expanded by same amount, then work done, and so see, then work done is in more in A compared to B, less in B, equal in both, and none of this. Okay, chalo. So what is our answer? See, for two spring A and B, spring constant of A is more than the spring constant of B. Both spring are expanded by same amount, then work done. So see, same amount means what, student? Here X same. Okay, here X is same. So if X is same, then what is work done? It means what? Energy stored in the work done means what? Energy stored in a spring. Energy stored in a spring is known as work done. So work done means what? Energy stored. So what is the energy stored? Half kx square. Work done means what? Work done means energy stored. And what is the energy stored? Half kx square. Okay. Chalo. So how to obtain, students? See here, x is same. So if x is same, so we can say that it is proportional to spring constant. It is directly proportional to spring constant. So work because both spring are expanded by same amount, so work done same. So we can say that this work done is directly proportional to K. So see which spring A is, spring constant of A is more compared to spring constant of B. So we say that work done in spring A is more compared to work done in B. Why? Because work done is directly proportional to K. Why? Because X is same. And work done means what? Energy stored in spring, means potential energy of spring. Sure. So now in same case, same question, students. Now restoring force is same. We repeat the same question, but here which quantity is same? They are both spring are stretched by both spring are stretched by same force. Now see students, here what is the next question? Both spring are stretched by same force, then what is the relation of work done? So see students, what is the formula of work done? Half kx square. But see students, now here x is not same but force is same, so તમારા ફોર્મ્યુલામાં force લાગુ પડે. We know the relation of k, ka is greater than kb, but here we do not know the relation for displacement. કયા સ્પ્રિંગમાં ડિસ્પ્લેસમેન્ટ વધારે છે એ ખબર નથી, but which quantity is same? Force. So આમાં તમારે ફોર્સને ઇન્ટ્રોડ્યુસ કરવું પડશે સ્ટુડન્ટ્સ. So how to introduce force? So F is equals to kx. So we replace x by what? F by k. So in the place of x we write what? F by k. In the place of x we write F by k. So half k, here we write F by k. So half k f square by k square. So f square by 2k. F square by 2k. So students, see here force is same. Force same. So what is the relation? See. Then what is the relation? Work done is inversely proportional to constant, the spring constant. See, if displacement is same, they are directly proportional. If force is same, both are inversely proportional. Okay, chalo. So now which have a more spring constant? Spring A have a more spring constant. So work done કેમાં વધારે થશે? B માં, because they are inversely proportional. So spring constant in A is more, so work done in B is more, because they are inversely proportional. Okay students, clear? So what is our not final and full? What is our answer, final answer? See one note students. For spring, if x is same, means expansion in both the spring are same, then work done is directly proportional to spring constant. Then work done is directly proportional to spring constant. And if force is same, they are stretched by same force. If force is same, then work done and spring constant are inversely proportional. Okay, chalo. So this is the work done for different case in a spring. Chalo. Now next we discuss students simple pendulum. Okay, next we discuss simple pendulum. Chalo. Okay, now we discuss students two types of pendulum, simple pendulum and compound pendulum. Students, what is the meaning by simple pendulum? See, in case of simple pendulum, we used light inextensible string, light string, and in a simple pendulum we used light and inextensible string, light string, then twistless string, inextensible string, twistless string એટલે સ્ટુડન્ટ્સ તમને ખબર છે ઘણી બધી સ્ટ્રિંગ હોય ઓકે એ ડ્યુરિંગ ધ ઓસિલેશન એમાં આમ ટ્વિસ્ટ થઈ જાય રાઉન્ડ. આપણે ઘરે કેમ ઓલા સ્વિંગિંગ કરતા હોય હિંચકા ખાતા હોય તો તમે આમ ટર્ન કરો એટલે આખું ટ્વિસ્ટ થઈ જાય આખું. તો બટ એવું ન થવું જોઈએ. ટ્વિસ્ટલેસ સ્ટ્રિંગ, inextensible string means during the oscillation there is no extension in a string, inextensible string, and we use small body but having finite mass, small massive body. Okay, light string, twistless string, inextensible string, and small massive board. So this is the what? Pendulum. Okay, so pendulum perform SHM, students. Okay, and see what is the length of pendulum L. Okay, what is the length of pendulum L? What is the time period of pendulum? 2 pi L by G. It means time period of pendulum is directly proportional to root L and inversely proportional to gravitational acceleration. And inversely proportional to what? Gravitational acceleration. But students, see, remember time period of pendulum does not depend on mass of the bob. Okay, or we can say that does not depend on the mass of its oscillator. Time period of simple pendulum does not depend on time period of simple pendulum does not depend on mass of bob. Chalo, so this is the simple pendulum, students. What is its time period? 2 pi under root L by G. And if we want to make a simple pendulum, then we used light string, inextensible string, twistless string. It is then we used from the fixed support, small body but massive body having some finite mass. And what is its time period? 2 pi under root L by G. It means this time period depends on directly proportional to root of length of pendulum and inversely proportional to gravitational acceleration. But this time period of simple pendulum does not depend on mass of the bob. Okay, so this is the simple pendulum. We discussed two types of pendulum, students. First we discuss all the cases for simple pendulum, then we discuss compound pendulum. Compound pendulum means what, students? Only one difference, here we use light string and connect a small massive body. But in case of compound pendulum, we connect a rigid body with the string. Rigid body means, suppose we connect disc and disc is rotated, we connect rod and rod is rotated, we connect ring and ring is rotated, then it is compound pendulum. But in the simple pendulum, small massive body is connected with the string. Okay, so now students, we discuss many type of cases. First we discuss pendulum in a lift, pendulum in a car, pendulum in a car moving in a circular road. After that pendulum in a liquid, pendulum in electric field. So there are many cases, okay, for the pendulum. But before the discussion, we discuss one force, students, that is pseudo force. I think you all know, but I explain again what is the meaning by pseudo force that you learn in a laws of motion, students. But first I repeat. So what is the meaning by pseudo force, students? Pseudo force means what? What is the meaning by pseudo force? So pseudo force is act in accelerated frame reference. Act in a accelerated frame reference without contact. This is the topic of laws of motion, but I'm a use also, so that's why we discuss. It is act in a accelerated frame reference without contact and in opposite direction of accelerated motion. In opposite direction of accelerated motion. So in that cases, pseudo forces act, students. For example, તમે બસમાં જાઓ છો સ્ટુડન્ટ્સ, અગર બસની સ્પીડ યુનિફોર્મ છે દેન તમને કોઈ ફોર્સ નહીં લાગે, મીન્સ યુનિફોર્મ સ્પીડ મીન્સ વિથઆઉટ એક્સલરેશન. બટ સડનલી બસમાં બ્રેક લાગે દેન વી આર મૂવિંગ ઇન ફ્રન્ટ ડિરેક્શન. તમે ક્યાં જાઓ? આગળ જશો થોડા, હે ને? સો બ્રેક ક્યાં લાગી? બેક સાઈડ. તમે ક્યાં ગયા? આગળ. સો ઓપોઝિટ ડિરેક્શન. કોઈ કોન્ટેક્ટ છે એમાં? નહીં. ક્યારે અપ્લાય થયું? વેન બ્રેક ઇઝ અપ્લાઇડ. બ્રેક મીન્સ રિટાર્ડેશન, સ્પીડ ડિક્રીઝડ, મીન્સ એક્સલરેશન ઇઝ ધેર. સડનલી બસ સ્ટાર્ટ થાય તો આપણને ક્યાં ધક્કો લાગે? પાછળ. Okay, so this is the pseudo force, students. Pseudo force always in the form for accelerated frame reference in opposite direction of acceleration and without contact. Chalo, so these are the basic 3 point for pseudo force formula. Same, students. F is equals to ma. Now next, students, our first case, pendulum in a lift. Case 1. Simple pendulum in a lift. Simple pendulum in lift. Chalo, so in this case, આમાં પણ અંદર કેસ આવશે. ફર્સ્ટ કેસ, lift is moving upward. lift is moving upward with acceleration a. Okay, lift is moving upward with acceleration a. So what is the first case here? Lift is moving upward with acceleration a. Chalo, so this is the lift. This is our pendulum. Now lift is moving upward with acceleration a. So students, एक force तो downward માં હોય જ mg. Now one more force ma is also in a downward direction. Why? It is what? Pseudo force that always act in a opposite direction of acceleration. So lift is moving upward with acceleration a, then pseudo force is in downward direction. Okay, mg is also downward, ma is also downward. So what is the resultant force now? So what is the resultant force? What is the resultant force? mg plus ma. mg plus ma. Why addition? Because both are in downward direction. So what is the resultant force? mg plus ma. Now in the place of resultant force we write what? mg dash. Now mm cancel. So what is g dash? What is g dash? G plus a. What is g dash? G plus a. And g dash means what, students? G dash is a effective gravitational acceleration. Okay, what is the meaning by g dash? Effective when more than two accelerations are there, or two or more than two, then it is known as effective. If only g is there, then it is gravitational acceleration, but more than two, then it is known as effective gravitational acceleration. Okay, effective gravitational acceleration. Chalo, so now what is the formula of time period? 2 pi L by g dash. So 2 pi, what is g dash? G plus a. What is g dash? G plus a. Chalo, so see student, now what is the effect in a time period? What is the effect in oscillation that we discussed? Means oscillation become faster, slower, that we discussed, student. If pendulum is in lift and lift is moving upward with acceleration a, then what is the effect in a time period that we discuss? So see students, here denominator increased, denominator become g plus a, so denominator increased, so it means time period decreased. Okay, time period decreased, students. So time period decrease means it take less time to complete one oscillation, and at one oscillation complete કરવા માટે ઓછો time જોશે. તો oscillation કરવા માટે ઓછો time જોઈએ, એનો મતલબ its oscillation become faster. Suppose earth अगर जल्दीથી rotation complete करे તો શું થાય? Time period decreased. Okay, so why time period decrease? Because denominator increase, time period decrease. Time period decrease means time required to complete one oscillation is decreased. It means oscillation become faster. oscillation become fast. Chalo, so now next case, lift is moving downward with acceleration A. Lift is moving downward with acceleration A. Lift is moving downward with acceleration A. So now students, lift is moving downward. So this is the lift moving with the downward with acceleration A. So mg is again in a downward direction, students. If mg is in downward direction, then pseudo force here upward. Why pseudo force is upward? Because lift is moving in downward direction. So pseudo force upward. Pseudo force is always in opposite direction. Okay, so ma is pseudo force in upward direction. So what is the resultant force? What is the resultant force? mg dash is equal to mg minus ma, mm cancel, so g minus a. So what is the effect in a time period? T is equals to 2 pi under root L by g dash. Okay, and what is g dash? Why both are minus? Because pseudo force and mg both are in opposite direction. Why pseudo force is upward? Because lift is moving downward with acceleration a. So what is our answer? G minus a. So see students, denominator decrease, g minus a, so denominator decrease, so time period increased. So time period is increased means oscillation become slower. Dhimu dhimu ફરશે, so oscillation become slower. Chalo, now third case. If suppose cable of system in a lift are break, cable break થઈ જાય students, તો lift શું થાય? Free falling. તો free falling થાય એટલે lift આવે તો ક્યાં? નીચે જ આવશે. કેટલા acceleration થી નીચે આવશે? g. So what are the time period? See, if lift is moving in downward, if cable is break, then lift to niche javse. So if, but here what is the acceleration of lift? G. Why? Because free falling. So if lift is moving in downward direction, what is the formula? 2 pi L by G minus A. What is the formula? 2 pi under root L by G minus A, when lift is moving in downward direction. So here we use what? 2 pi. But see students, what is the acceleration of lift? G. Why? Because free falling. So G minus G is 0. So what is the time period, students? Infinite. It means oscillation stop. Time period becomes infinite for free falling of lift. Lift is moving upward. Lift is moving upward with uniform speed. Lift is moving upward with uniform speed, student. If speed of lift is uniform, then what? Uniform speed means acceleration 0. So it means, students, acceleration 0, then no pseudo force is act. Okay. So अगर pseudo force नहीं हो तो एक ज force हशे mg, then what is its formula? Same, L by G. ओके, अगर एक्सेलरेटेड फ्रेम रेफरन्स हो तो सूडो फोर्स एक्ट थाय एंड तो एनो टाइम पीरियड चेंज थाय, अदरवाइज इट रिमेन सेम 2 पाई अंडर रूट L by G. सेम अगर इफ स्पीड इज मूविंग डाउनवर्ड with the uniform speed, then and then again acceleration 0, uniform speed then acceleration 0, तो પછી lift upward હોય કે downward, students, time period remains same. Okay, for uniform speed acceleration 0, if acceleration 0, then no pseudo force is acting. Okay, then the time period is same 2 pi root L by G, whether lift is moving upward or downward. Chalo, so in next lecture we discuss pendulum in a trolley, pendulum in a car moving in a circular road, pendulum in an electric field, compound pendulum. Okay.